Good day, ladies and gentlemen. Today we're going to go into the damage system as well as integrating health bars. We're also going to look a bit into ranged and melee combat as well as support for 2D and 3D functions. So we have three agents in our scene: Agent, Agent 1 and Agent 2. And Agent 2 has a health bar. It's a very basic health bar, it's just a canvas with some images and text, whatnot. But first, before we progress, please make sure that you have version 1.0.1 installed. As of recording this video, it hasn't been, it is not live on the Unity Asset Store, but you can download it on GitHub. There is a link in the description of the video to the GitHub repository, and you can download it from there. So now let's jump in. You can find a lot of health bar assets on the Unity Asset Store, as well as tutorials online, such as on YouTube. We also have a camera follow script attached to our camera that's going to focus on our sphere so that we can easily see changes to the health bar. So if I run the scene, everything is fine. Our agents are following the sphere, and great, we receive damage. But now if you notice, our health bar is not moving. Why is that? That's because we haven't really done anything Candice does not know this health bar is there. So we have to intercept the receive damage function that is within the AI controller, and in that function is where we're going to put our health bar code, in a sense. So let's first find this function. So we're gonna go into our AI controller script, Candice AI controller, and there it is. So the receive damage function is basically right there. So this function is called whenever our agent receives damage, whether it's from other agents or the player or wherever. This is the function that is called, and in order to call it, you get a reference to the game object and you call the function send message with the parameters, which is the function name and the damage. I'll show you that now. It's as easy as this. This is it. This is how our agents can damage each other and how you can damage the agent. So you get a reference to the game object, and then you call send message function, and in that function the first parameter is the function name, which is, in our case, it's receive damage within the AI controller, that function. And from there, the second parameter is the float, the damage. It is what will be passed there. So that's it. Doesn't matter where you're calling this from. It can be from whichever script you want. You just get a reference to the AI agent or object, the AI agent you want to damage. You get that game object, and then you call send message, and in there the function you want to call and the parameters, and that's it. That's how you damage the agents. From here, this is where we want to put our health bar code, but first we need a reference to our health bar. So let's go back to our scene, and here's our health canvas and our health bar. This is the script that actually does everything for us, and the script doesn't really have to be here. So what I want to do is I want to move the script to the agent so I can easily get the script. I could get it by getting the child, which is the health canvas, then get the child of that, then get the component, but that's going too deep. And imagine if I have 1,000 agents, that's gonna slow the machine down. So I'm just gonna move it straight to the agent, the script. There we go, and that's fine, because the only thing the script does not have to be there. It already has the references to everything it needs, which are those things you see there. So now, once we've done that, I can get a reference to it. So first thing I'm going to do is create the health bar object. I have to import it. Awesome. So now for this specific health bar implementation, we need to, at the start of the scene, we need to set the max health. So first we're going to get a reference to it. Health bar is equals to get component. It's going to be of the type health bar. And then we do a null check. So if it's not null, then we can say health bar dot set max health. And fortunately, we have a max hit point property in our AI agent for no AI controller. So now this is it to set it up. From here, all we need to do is now intercept the part where we receive damage, so we can set the current health bar value as we receive damage. So in our receive damage function, fortunately for us, the combat module does that calculation for us. It minuses the damage, and if the damage exceeds our current hit points and becomes negative, we just set it to 0. So this hit point will never really be less than 0. So we do a null check again. If health bar is not equals to null, then we say health bar dot set health, and we're gonna say hit points, and that's it. From here we can actually run our project and see what happens. So our agents are following our sphere as normal, and here we go. And as you can see, we are receiving damage. That's great. So it's that simple to implement a health bar system. It all depends on what kind of system you're implementing health bar, but generally what you want to look for is the script that controls the slider, this slider for your health bar. And in my case, in the case of this health bar, it was this script, the health bar script. So a lot of, I don't want to say most, but a lot of other implementations will be like this, and as long as you know how to code a little bit, you won't really get stuck with this. It's very easy. So from there, we want to look at ranged and melee combat. So right now, our two agents, agent and agent 1, were attacking using melee combat. But now, what happens if we want to make them attack ranged? In the behavior tree mono, I'm going to change the attack melee to attack range. Or better yet, no, I'll just use the aggressive AI range because I already have a function here. So now the only difference between the aggressive AI melee and ranged is that the attack node calls attack ranged instead. I can see here it's calling attack melee. I should change that to attack range. That's it. So now, to get our ranged attack to work, we need two things: a projectile and a spawn position. So fortunately for us, we have a spawn position right there in our agent prefab. The spawn position can be anything. It's just a transform. It just needs a transform. So basically a point in space where the projectile can spawn. From there, we just need the actual projectile, and we also have a prefab here in our prefabs folder that has the Candice projectile script. So it's a basic game object. The only thing it has is a collider that is compulsory, and it also has a rigid body. And from there, just the Candice projectile script. Those are the only things you need for your projectile. You don't need to worry about the target nor the attack damage. That is controlled by the agent. It sets those properties. So all you have to set is the move speed. The faster, obviously, the faster the projectile will be. So in our case, 2000 is very fast, but you'll see it's not actually that fast. You'll be able to see the bullet. So in order to get an actual bullet, I would say maybe 10,000 to 20, but it'll depend on your game, on what projectile you have. Then we have destroy and collision. That will destroy the projectile will destroy itself as soon as it collides with the first object it meets. And then we have destroy after delay. The projectile will destroy itself after a delay, and destroy after delay takes priority. So I'm just going to deactivate that because I want to destroy this thing on collision. And from there, I don't want to use force as well. I don't want to follow target because this is just a bullet. And yeah, I want to stop on collision. Those are basically the properties you're going to want to manipulate. Is fired and collision delay are more like are used internally by the agent. So those two are gonna disappear eventually. Yeah, but other than that, these are the properties we want for the behavior we want for this bullet. So now I'm going to run my scene. Okay, the agent is behaving normally. Alright, let's see. Hey, and there we go. Our projectile is being fired and our agent is losing health. You see, 2000 was not that fast actually. It was pretty slow. So to get an actual bullet, I would say maybe 20,000, probably 10 times speed. Maybe 10, you can get away with that. But other than that, that is in a nutshell how our ranged combat works. So, how are we going to get our system to work with both 2D and 3D games? Well, the good news is our system supports that at the core level. The bad news is you're going to have to implement those functions yourself. There are some basic functions for 2D scenarios, but not everything. It's the same for 3D as well. There's some basic functions for the behavior tree, but not everything. We have, for example, we have move forward and we have move forward with slope alignment. But you're probably going to want other move forward. You might want move backwards or move up. For example, jump. There's no jump function, you see, and you're going to need that for both 2D and 3D, you see. So at the agent level, the agent does not know what kind of game it's in. It doesn't know whether it's 2D or 3D. It does not know. It just knows that it has a function to run at a specific time. So that function may be a function that works in 3D space or works in 2D space. Heck, it might even work in 5D space if we could get that far in technology, you see. So again, it all depends on the functions you implement. I'll give you an example. Where are my default behaviors? Let me find it. Awesome. So as you can see here, we have scan for objects. Okay. And this, it basically calls the scan for objects function that's within our AI controller. So let's go to our AI controller, Control F. There's our scan for objects, you see. So this function, the agent does not know that this function is for 3D. It just knows it's a function and it's going to run this function, you see. So, and as you can see here, we have another function, scan for objects 2D. So how are we gonna, the agent does not know, you know, we just use these functions. It's that simple. So to implement this scan for objects 2D, the only thing we need to do is go to our Candice default behaviors and actually implement it. So I'm gonna copy this. I'm just gonna paste it and change the names because it's exactly the same thing. Okay, so now I'm just gonna paste the scan for objects, and I'm gonna change that to 2D. Oops. And I'm gonna call the scan for objects 2D in the AI controller also. So now that's it. Now we're calling scan for objects 2D. But now one thing we should not do is just put them here in the middle of everything. If you have a new function you want to add, you need to add it at the bottom. Why do you want to do this? Okay, so if you had, I already do have it here actually. So yeah. But anywho, if you put it somewhere in the middle there, it will still work. Any new behavior tree you make will still be fine, in a sense. But old behavior trees will kind of break. But that only applies to the Candice behavior designer. As of recording this video, however, it has not been released yet. So for those of you who are creating behavior trees through code, you're safe, and this does not apply to you. But for those that will inevitably use the Candice behavior designer, this will unfortunately apply. So I want to say thank you for watching this video, and if you enjoyed it, don't forget to like and subscribe.